Okay, a lot of times students will ask me, well, Dr. Wabi, what kind of questions are you going to ask us about quantum numbers? And what I decided to do in this video is just basically take out a couple of problems that I have asked on exams in the past and just introduce them to you so that you know how to approach this topic. Number one, you need to know the definition of each one of them. You know, what is the principal quantum number? What is the angular momentum quantum number? What is the magnetic quantum number and what is the spin quantum number? And know, which one's N, which one's L, which one's ML, and which one's MS, and know what the possible numbers are for all of them. And then towards the end of the video, the last video, where you need to be able to tell me which 4 quantum numbers are permissible and which are not permissible, just like we did in that last video, okay? And then in addition to that, here are a couple of other types of questions that you need to be able to think of and be able to answer. And not necessarily these, but worded pretty much in the same way. So for example, first question over here, hopefully you can see it. It says, what is the value of the angular momentum quantum number? So angular momentum is L. What is the value of the angular momentum quantum number in a 1s orbital? Remember how we said L is equal to 0 is S. If L is equal to 1, it's P. If L is equal to 2, it's D. If L is equal to 3, it's F. Remember how I said that in the last video? So this question's pretty easy. This one, L would have to be 0. Any S, whether it's 1s, 2s, 3s, 4s, any S subshell, basically a sphere, S is a sphere, is going to have an L value of 0. I don't know if you remember this from the shapes from Intro Chem. S is a sphere, and P are dumbbells, and then you get that clover leaf for the D. Do you remember those? Anyway, look, you can look those up. All right, so that's the first one. If instead of saying an 1s orbital, they had said a 1s subshell, it's the same thing. L is equal to 0. What if they had said a 2s orbital? L is equal to 0. Okay, and how do I know it's L? Because they're asking for the angular momentum, and angular momentum is the L. Okay, here's the next one. A possible value of the magnetic quantum number. Now, magnetic quantum number is ML. Remember, in order to get ML, you go minus L all the way up to plus L. So a possible value of the magnetic quantum number for a 5p electron. So the 5 is not important, it's the P. P will tell you what the L value is. Remember, S, L is 0, P, L is 1, right? So if L is equal to 1, which we know it's 1 because it's a P, then ML, what are the options for ML? They could be minus 1, 0, plus 1. So to answer this, a possible value of the magnetic quantum number for a 5p electron, these are the possible values. It could be minus 1, 0, or plus 1. Okay, here's another question. How many values are there for the magnetic quantum number, that's ML, when the angular momentum quantum number is 3? What is angular momentum? That's the L. So if L is equal to 3, what are the possible ML values? ML, remember it's plus L all the way, minus L all the way to plus L. So the possible M values are minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 7 possible values. Because when L is 3, that is the F subshell, and the F subshell, if you remember from intro chemistry, holds a maximum of 14 electrons, and each orbital holds 2, so you have 7 orbitals in the F subshell, okay? All right, and then this last one says, sure you see it. Last one says, how many orbitals have the set quantum numbers n equals 4, L equals 2? Again, it's all about the L. N is just the shell. Okay, so we're in the fourth shell, yay. But we're in the D subshell. Because remember, if L is 0, it's S. If L is 1, it's P. If L is 2, it's D. So if we're in the L is equal to 2, how many orbitals do we have? Well, we figure out the orbitals from the ML values. What are the possible ML values? -2, -1, 0, +1, and +2. Okay, those are your possibilities. So, and each one of them represents an orbital. So how many orbitals do you have? 1, 2, 3, 4, 5, 5 orbitals. Okay, so that gives you a feel for the types of questions you might see on an exam relating to quantum numbers. So really, chapter 7 is a pretty straightforward chapter. If you know how to do the 4 equations that I told you, and you know how to manipulate them properly, and you can do algebra, which I know you can, and you understand the quantum numbers, and you can answer these types of questions, you're going to be totally fine on the chapter 7 material. Okay, we're all set, and the next video will be chapter 8.